Hello guys, welcome back for another video, and in this one we are going to talk about RAG system architecture. So all those RAG work, and RAG mean retrieval augmented generation, and it is typically used with LLM to make sure that LLM have the right context for the answer, and it's very useful when, like for example, you use an open source model that have been trained, for example, for a limited period of time, and you have like context that just dropped, and for example, your LM cannot answer on this. So the idea is to give it to add this ability to your model to have more context, and we typically do it with RAG. Okay, and it's less costly that retraining and easier to make this in place. Okay. So the first thing about RAG is the following. We need first document that the LLM will use as context for partially with text. So we have source document, can be anything, can be presentation, can be text, can be PDF, anything that we can extract text from. Okay. So the idea is once we have selected our pool of text, pool of sources, the idea is to divide those text into limited chunks, and those portion of text there is like different type of technique to divide the text. You can have like a split evenly. So for example, every like 200 of line, you just like create one portion of text. So it will be one chunks. You can have like chunks by sections. So for example, if you have a paper, you can have like chunks: intro, background, methods, result, experimental conclusion would be more meaningful. You can have like more elaborated chunking techniques with like meaning. So you have first LLM that go through the text and try to see what are the section and or do they differentiate, and then you have like a specific like chunking for your PDF. But this is the idea. You have text, and then you split it in little parts, and then those little parts are then fed into a model that is basically a embedded that will basically take this text and create a vector representation that will be used to identify what are the similarity between the texts that were created with the small chunks and the user query. Okay. So now we have vectors. So for each chunks, we have like vector, and those vector are then put it into a vector database. So for example, it can be like mildew, can be like quadrant, any kind of vector base that you want to use. Then the idea is to do the same with the user query. The user type a text, this text in the same way. Use the embedder to create a vector, which we'll call the query. And then the idea is from this query, we want to like do some kind of dot product, which will calculate the similarity between the query and the different chunks. Okay, so it's basically doing semantic search. And the idea is that we want to compute this for all the chunks. So that's why we want to index this in vector database, so we can do like vector multiplication with matrices. And so we can search all of those like in a very optimized and fast way. Okay, and then we can get scores for the query versus the different chunks, and for every chunks, for example, maybe the ID of chunks 1 and 3 gives like the most similarity with the query. And then often what we do is for RAGs, we use top K retrieval. So for example, we take like if we like have like a method that use like 10 chunks, if the result like gave 10 chunks, we for example want 3 chunks that gave the best score. In all cases, and the window now representing its top two, sorry. So just taking the two best score with the dot product, okay? And so now we have like best score for 1 and 3, and those vector will be taken. Then we'll use this index, so 1 and 3, and we will get the text chunks back. And the idea is from the prompt that we have, this will be added. Most of the time, the different library that we have now, so LangChain, Llama Index, True AI does this for you directly, so you do not need to re-implement this. But the idea is still the same. What is beyond behind the code is this simple structure. So you just get those two relevant chunks, and the idea is to have a prompt that's have the user query and just have like some kind of small text that say based on the following context below. And then the two chunks are then used to respond to the user. And then this text is given to LLM, and then the LLM is able to provide like an answer that is this time if the user did not like added this context, for example, and was questioning like, for example, today event without having like any context, the model will definitely given like an answer, but it will have like hallucinated. And now since gave like it used RAG, and most likely the chunks that were used for were aligned with the query, the response is like more aligned with the context, and more user can get like a more informed response. Okay, so that's how RAG is working. I hope you liked the video, guys. I made other video on all like LLMs work on all like RNN. So you need to watch those videos if you are more interested in to understand those type of models. If you liked this type of content, please like and subscribe to the channel. It's what helps the channel and support the channel. And I will be seeing you in the next one. Bye bye.